Okay, and then we move forward with our next presenter, which is a known face to this event. His name is Anton Lazarev, and Anton is basically Brave's resident AdBlock engineering expert, and a repeat presenter at our summit, which is great. And he's always looking to push the frontiers of open source and to build technology that really puts users first. And Anton's talk is titled Agents Need AdBlocking Too. And he will basically be exploring how Brave is evolving AdBlocking for an AI era, including the role of agentic browsing and, basically headless browsing, if you will. And curious to hear what you have for us, Anton. Please join me on the stage.
Yeah, so agentic browsing is probably the biggest buzzword in the browser industry in 2025. You have all these small venture-funded startups trying to build something quickly in the space. You have all the big tech established players trying to build something in the space. Lots of hype around it, but maybe you as a user of browsers haven't experienced much of a difference in your browsing this year. So I want to quickly explain what agentic browsing is, just to make sure everyone's on the same page, and then we'll talk a little bit about what that means for the ad blocking industry. So with agentic browsing, you don't have a browser window, you have a prompt. And it's just a text box. You're going to type into it a question, something you're curious about, something you want to do. And your agentic browser will read this prompt. Let's say my prompt is that I need to book flights for the Ad Filtering Dev Summit. And I'll press enter and I'll get a response that the browser is thinking about it. And it'll wait for, some time. Eventually, I'll get a response saying, okay, my flights have been booked. I should get email confirmation shortly. Maybe I can get them added to my calendar if I want. And so this is kind of cool, right? I never actually had to touch a web page. I never had to enter my personal information into some fields. I think the browser just handled that for me. It had it in a database somewhere. So that's awesome from a usability standpoint. But it also raises some questions about our industry because, where is the browser window? If you're not using a browser, how can you use an ad blocker? And what does that mean for people who work on ad blocking, for filterless maintainers, engineers, that kind of thing? Is our industry dead?
No.
Yes, it is evolving. So basically, I feel at Brave, we are working on, we have the best natively integrated ad blocker that isn't limited to an extension API. And we're also working on AI technology, so I feel I'm in a pretty cool position to tell you about some of what might be happening in the future of ad blocking as it pertains to AI and agentic browsing. So I want to kind of share 4 case studies of what this might look like going forward. One is direct agent use. So if we go back to this previous example, in this agentic browsing session, there actually is a browser behind the scenes. You just don't get to see it. So what happens while the response is thinking is you actually get this chain of thought generated by the LLM. And this all gets hidden from the user, but it happens behind the scenes. And so in this case, it'll decide that in order to do this task, it needs to figure out where's the location and the date of the Ad Filtering Dev Summit. So it'll perform a web search, and it'll probably find the official URL for the event, and click on it and see all the information about it and extract that out of the page. And then maybe it'll keep iterating on this task and say, okay, it's a long flight, and he said he was talking at the event, so maybe we need to make sure he's well rested before the event starts, so I can start booking on October 18th rather than right before it. And so it'll do another search for flights on those kind of dates, and it'll keep doing this until the task is completed. And so the browser window is actually in those steps. And so the way this is implemented is you have a browser that is either headless on your computer or in the cloud somewhere, and it's going to be executing all these tasks as if it were you, the user, but it's just an LLM driven by your prompting. And as it turns out, browsers are one of the most complex pieces of engineering we have, and visual LLMs are also really expensive to run. You might be familiar with text LLMs being expensive to run, and with visual LLMs, well, you've heard the saying, a picture is worth 1,000 words. That happens to be true in terms of token usage for AI as well. If you have a screenshot of a page and you try to pass that to a visual LLM, that can easily be 1,000 tokens or more worth of words. So the easy way to optimize all of this is using an ad blocker, right? We already use ad blockers in our browsers to make the browsing faster, to speed up our tasks, to increase the battery life of our devices. And the more that you can reduce this cognitive load and requirements on the visual LLM that is doing this agentic browsing, the better of an agentic browser you will have. And so it's kind of a no-brainer to include an ad blocker in your agentic browser, and you're doing it wrong if you're not adding one. So next case study I want to show is training data cleanup. If you're not familiar with how like a normal text LLM is trained, basically somebody will acquire a huge data set of online documents. These are usually just web pages, and they'll collect them using a scraping tool and assemble them into a training data set. And then they'll throw a whole bunch of electricity and GPUs at the problem, and eventually it'll just produce this nice LLM, and that LLM will be very good at reproducing text patterns from the original documents that you provided. So you need to have a large set of documents, very diverse, and they also have to be very high quality, because this training process does not fix data quality problems. If you put in a bunch of low quality documents into your training data set, then you will get a very low quality LLM as a result, and you're not going to like the text that it can generate. So one interesting thing about this process is that your LLM generates text, but your online documents are probably web pages. So if the LLM is generating things similar to the input training data set, then it would have to generate web pages, right? So how do we turn the web pages into text? We use a process called serialization, and you can see, on an average website, if you take all of the HTML tags and strip them out and put it into this linear text format, you're probably going to get a lot of like junk in your training data set, right? You'll have cookie notices, you'll have promoted content, you'll have sponsored content, and anything you train on this data is probably going to be really good at inserting a cookie notice and some sponsored content into the middle of your discussions with it. So that's not going to be fun. And so if you insert an ad blocker into your scraping program, you'll actually be able to get much more high quality data out of the scraping process, and thus you'll get a higher quality LLM in return. And this isn't hypothetical. I one day was just looking at the dependency graph of things using AdBlock Rust, which is Brave's own AdBlock engine. And I found this spider tool on GitHub. And they are literally embedding AdBlock Rust inside of the scraping tool. So scrapers are literally first-class AdBlock users, and that has some implications too. You can imagine it would be really weird if somebody made a filter list just to strip out headers and footers from websites, but maybe for a scraping tool, for LLM training data, that actually makes sense, right? So something to think about. Another case study here, tools for list maintainers. For those of you who were here last year, you probably might have remembered my talk about Cookie Crumbler. This was a tool that I designed to automatically detect whether or not there is a cookie notice on any given web page. And as it turns out, back then I was talking about how it used a very naive keyword-based algorithm to detect cookie notices. So it would search for words like cookie or privacy or analytics or accept, reject, things like that. I mentioned that it might be possible to use an LLM to detect these things. And I'm proud to announce that this year we've been running LLM-powered Cookie Crumbler in production, and we've had really great success with it. We have a huge constant influx of new cookie notices that are being detected. And we have so many of them, in fact, that we decided to pretty much open source all of these reports and put them into a GitHub repo. Ryan over here is our resident filter list maintainer for EasyList Cookie, And as much of a superhero he is, he's still struggling to keep up with all of these. So if anyone is curious, if you have an hour or two to just like knock out some cookie consent notices, this is a cool task for you maybe. But the real implication here is that cookie notice coverage is really no longer limited by the by the volume of reports that users are submitting. In the past, we've always relied on some level of breakage that users would encounter when using an ad blocker, and they would report that to filter list maintainers, who would then fix it and push out the fix to everyone else. So that basically just meant that you can't expect a 100% reliable experience when using an ad blocker. But with tools like Cookie Crumbler, we can actually start to push that failure rate to 0, because we can solve these issues through proactive crawling before anyone ever even visits the site that has updated to have a new cookie notice or update an existing one or something like that to make the filter lists not work anymore. So that's a pretty cool experience. And I think that tools like this will become increasingly popular and increasingly used in the filter maintenance space. So watch out for that. And final thing I want to highlight is MCPs. And for anyone who isn't familiar with MCPs, it stands for Model Context Protocol. And that is a standard way to describe tool calls to make them accessible to LLM agents. And you can think of a tool call as like any operation that you might do on a computer. So say reading a list of things from a website, or sending an email to somebody, or creating a calendar event. These are all examples of things that you could turn into an MCP server and make it accessible to an LLM chat partner. And since that's kind of abstract, let me give you another concrete example. Hopefully you can see it. So continuing the example from previously, let's say I wanted to have my chat agent use an MCP server to book an Airbnb for my trip as well. So I'd ask it to find a cheap Airbnb and make sure it has good Wi-Fi. And it would output a chain of thought using the context from previously, saying, okay, this is actually happening at the Crowne Plaza Hotel, and it'll need to book the same dates as the flights that it booked. And so it'll output this special looking JSON blob here. And that JSON blob is not like random. It actually corresponds to the format for this particular Airbnb MCP server implementation. And that allows the chat agent to have access to the Airbnb service, essentially. And you can see that the JSON arguments here correspond directly to the Airbnb search tool provided by that MCP server. So you can see that it is using a location parameter, check-in, check-out, and max price. And those are all listed in the acceptable parameters for the MCP server. And so once the LLM client realizes that an MCP tool call has been produced, it'll stop the LLM from generating text, send this blob to the MCP server. The MCP server will do some processing on it, make some network requests to Airbnb, and get results back, and then fill those back into the LLM's context. And as a result, the LLM will be able to see all of the results that it just fetched, and it'll be able to continue reasoning based on those results. And in this case, maybe it decides that the first listing looks really promising, and it'll inspect it closer to make sure that it's close enough to the hotel and it has good Wi-Fi. And so it'll call the next Airbnb listing details tool and continue with that process. But it's still kind of confusing, right? There's no browser here, there's no filter list, there's no adblock engine. This is all just like an LLM agent making a request to a server implementation that's doing a forward directly to some backend server, getting a result back, sending it back. So like, why am I talking about this? Let me make the connection for you. This is like a normal website that you might be used to seeing online. Of course, we would use ad blocking to improve that experience and strip out all of these annoying or useless elements from the page. And that's pretty cool, but that also leaves us with a couple things that maybe aren't ideal, right? So if there's a nav bar at the top where They put all of the most profitable things in it on the first level. And then if you want to get to the thing that you're actually interested in, you have to like hover over it and go through 3 submenus and click on that. Or maybe they put important things on different pages that you have to open multiple tabs and juggle them all together. So with MCPs, you're basically turning this whole paradigm upside down. And rather than stripping out the bad things from a page, you're skipping the page altogether and only pulling in the good parts. And these are all essentially done using community-maintained server implementations, which are pretty simple. It's just a description of an API and a little bit of a glue code to connect that to an actual backend server and pull results back. Oops. So MCP is widely supported in coding clients and other desktop chat clients as well. And there's also a dramatically expanding number of MCP server implementations. So essentially that Airbnb thing, you can imagine having one for Google Flights, you can have it for your email inbox, you can have it for your calendar, things like that, right? Or maybe some shopping sites. And these are all basically supercharging your LLM agent into being able to gain these capabilities without you ever having to visit the website itself. And just to emphasize how many of them there are, if you click on that last link, you'll get to this page. And this is like, I recorded a small video here. So it'll scroll through here and keep an eye on the scroll bar just to see like how many of these there actually are. It's a lot. So at the top, those are the officially maintained ones released by the service provider. And the bottom ones are like community maintained ones. And it's pretty similar to how filter lists work, right? Your ad blocker will have community maintained filter lists in it. And you might customize that with additional community maintained filter lists for special sites that you visit, some region that you are in. With MCP servers, you might also customize your LLM chat agent to include services that you use on a regular basis. And so there might already be some MCP server implementations for services that you use regularly here, but it's pretty easy to make your own. And I think that's a interesting space to watch in the future. So those are the things I wanted to highlight, and I think it's clear that ad blocking is not going anywhere. We will still have browsers for a long time, and I'm sure there will be a long tail of cases which agentic browsing won't be able to cover, even when that's a thing. But yeah, that's about it. Happy to take questions.
When you started the part about MCP and the relevance to ad blocking, I was expecting that you were going to say that MCP will include ads in the responses and you will have to block that. I didn't hear that, but do you anticipate that going to happen?
I'm sure that will happen, yes. But the cool thing about MCPs is that if you have an open source MCP implementation, even if it's like the officially maintained one that Airbnb has produced, for example, right? And they decide they want to include ads in their listing, you can easily fork that implementation and just strip those ads out, right? It's just like code that's running on your computer or whatever. So that's pretty cool. I think we haven't really seen that being too much of a concern yet. I don't think there's been enough adoption yet, but I can totally see that being a thing where somebody will disagree with fundamental decisions made by an official MCP implementation and decide to create their own based off of it.
Are you prepared to already implement that filtering when that time comes?
Sorry?
Are you already prepared to implement that filtering when, it becomes necessary?
Yeah, I guess we'd have to see how that works out in practice. I think most of it will be done at the implementation level and wouldn't need an external filtering tool on top of it. But I see a lot of parallels between having a filter list and having some MCP implementations. So you can kind of imagine maybe pulling down all of the MCP server implementations from your favorite MCP maintainer, right? Somebody that you trust.
Oh, hey. Great talk. And what I'm about to say is more of me thinking out loud right now. So I understand that ad blockers are like for us humans, like users. It's a great thing. It's just like you don't want to keep your privacy. You just like don't want to be bothered by ads and stuff. But that led me to think that for AI, like ads on its own, it's not like an absolute evil like that you should just like get rid of, or it's not like a virus that you should eliminate. That made me think that for the LLMs or for the web crawlers or for AI in general, wouldn't this be like just feeding the AI like very pure data more than it should? Wouldn't this be I don't know, like if the web crawlers are meant to just browse the internet and click on everything and click on ads and not ads, and that's how they should, I don't know, it's like a baby and you just like let it learn everything, with the good and with the bad. So don't you think that teaching AI or like modeling, teaching a model with a very very specific data that has no ads, that has no noise, wouldn't this be a little bit like, I don't know, an extra thing to do? Like it shouldn't be that strict.
Yeah, it's a good question. I think, I mean, even us as humans, if you were to disable your ad blocker right now, I suspect next time you try to like download something from a site, you'll see all those like sketchy looking download buttons that maybe look like the right one, but you're not sure, and then you click on it and suddenly your computer is infected by malware, right? So I don't think that problem will ever go away, and I think ad blockers are literally the right solution to that, because it's much easier for an ad blocker to figure out which element is the correct one and block everything else based on a filter list than I think it ever will be for this continuously adversarial game of like trying to make the scam download button look even more similar to the real one, you know?
Even comparing this to the, I don't know, like the kind of insightful ads that might actually be giving you some good product to click on and to see, I don't know, like you're searching for a flight from this to this, and there's that company that show you an ad, and it's like it's an ad that would let you know that there's a cheaper price here.
Yeah, I guess potentially if there's a one of the sponsored things at the top of the list is actually a cheaper item, then that usually makes sense. But in my experience, if you actually look at the top item that's promoted, it's going to be a worse value in like every aspect compared to the non-sponsored ones. I think that's just how it plays out in practice.
Got it. Thanks.
Hey, have you been able to measure like performance impact or monetary impact of ad blocking running in agentic browsing? Basically, how much faster you can actually get the browser to be with the ad blocker on, or how much cheaper it turns out to be if you have to process less tokens?
Yeah, it's hard to say specifically because that would be highly dependent on like what implementation you're using. But in my experience, so I've tried like Cloud Computer Use, for example, because you can run that locally. And what that does is it essentially will like, you give it a prompt, and then it will run this loop where it'll take a screenshot of the browser window, process that screenshot, decide on the next course of action. Maybe it finds like there's a button to click on, and it'll say, okay, I'll click on these coordinates. In practice, that process of reasoning about the screenshot isn't instant. There is some latency there. And so if the page happens to have a pop-up that appears on top of that button before it's able to click while it's reasoning, then it'll click on the pop-up, something unexpected will happen, and it'll just throw the whole process into this chaotic spiral of like, oh, I don't know what's happening anymore, let me try something else. So that doesn't work extremely well. And you can also just imagine like, even if it's not a race condition between these things, if there is a pop-up, your LLM will have to reason about, okay, now I need to close the pop-up. Let me click on the X, find the X button, click. And so that's just like an extra iteration or two, which there's no reason to run it if that's not part of the task that you're trying to accomplish, right?
I mean, what I asked is also like if we have some kind of benchmarks. Like we know that for instrumented browsing, like let's say Puppeteer, if you just scroll a website with an ad blocker on, you can get anything between 25 to 50% like speed boost or less energy being consumed, depending if you have a screen or not. I guess you could run the same with for the Edge browsers. You have an ad blocker on off and see what's the impact. And the question is, if you could run such benchmarks.
Yeah, potentially. I haven't run any benchmarks like that myself. I haven't seen any, but you can definitely imagine, like, you have to run the browser anyways, so you're already getting those savings, and then any savings that you get by simplifying or speeding up the process of browsing through the page, even if it's just like you don't have to scroll past ads as much, that all speeds up the process even more. I think in practice, the agentic browsing loop, the energy cost of that is definitely dominated by the LLM, but it is saving there in both aspects. Thank you.
So, bad actors and MCPs, if a bad actor took over an MCP and say, if you were trying to search for a hotel and you're not knowing that maybe an MCP has been compromised and you hand over your credit card details, and how would you protect something against, I guess, bad actors? Like, I guess with any scripts, there's some level of trust that the ECP is legit and not compromised, but there's always that case where maybe you are trusting potentially a lot of personal details within MCP.
Mm-hmm. Yeah, it's definitely a potential problem. I don't know if we've seen any examples of that yet, just because MCP is not widely adopted enough. But I think we will get to that point, and there definitely is a lot of unanswered questions about the privacy and security implications of using an agentic browser. I know we at Brave have literally just published a few studies analyzing some of the existing agentic browser prototypes and chat agents and things like that, and we found a lot of problems with it. So those will have to be solved before this can be massively adopted for sure.
Okay, looks like we're good. Thank you, Anton.